Suppose you were asked to differentiate this rather awkward looking function. Hopefully you can identify fairly quickly that we have a product here, and so we need to use the product rule. Now this root 5x plus 1, anytime you want to differentiate or integrate, it's much better to use power notation rather than root notation. So 5x plus 1 to the half. And for v, a much more straightforward 2x minus 3. So u dash equals a half 5x plus 1 to the power negative a half times, because of the chain rule, times 5. So we've got 5 halves 5x plus 1 to the power negative a half. Some people might now be tempted to recognise that this negative power means that we have a reciprocal and rewrite this as a fraction. It's not wrong, but it's not helpful either. Let's leave it like this. V dash is a much easier 2. So dy of dx using the product rule. The first times the derivative of the second plus the second times the derivative of the first. Gets us to there. That's the differentiation done, but as we've seen before, the hard work begins now because we've got to simplify this thing. Tidy it up. Now, common factors. It's not completely obvious, but you can see that both of these two terms do contain 5x plus 1 to some kind of power. Let's start there. Let's remove 5x plus 1 to the power of something as a common factor. The question is, what power is the best to use? The general principle that I want to give you is that you should use the most complicated common factor that you possibly can. And I would argue that a power of negative a half is more complicated than a power of positive a half. Use the most complicated common factor that you can find. Now let's see where we go with that. We need to allow for that too. And 5x plus 1 to the negative half multiplied by something has to make 5x plus 1 to the positive a half. This is where you need to be up on your index laws. It's going to be some kind of 5x plus 1 to the power. Remember that when you multiply, as we are across this square bracket, when you multiply, the powers are added. So negative a half plus something has to make positive a half. And that's actually a very easy power 1. So that's now working to make this first term. The second term, we've got to allow for that 5 halves. We've got to allow for that 2x minus 3. But this 5x plus 1 to the negative half, we've already dealt with that. So that's the second line. Now that we've taken this complicated common factor out, we can just leave it there. It just drops down from one line to the next. Most of our work now is going to happen inside this square bracket. Power 1 is just very straightforward. What we have here is 10x plus 2, nothing complicated about that, plus 5 halves times 2 is 5, so plus 5x, minus a slightly awkward 15 halves. Gets us to there. 5x plus 1 to the negative half. Now what can we do with this? Well, 15x. If we're going to combine these two terms here, we need a common denominator. So I'm going to treat that as 4 halves. 4 halves take 15 halves makes negative 11 halves. Now that's not so nice having that fraction inside there. So what we're actually going to do is we're going to remove another common factor. I'm going to remove a factor of a half from here and pull it all the way out the front. And that means, just tidy this up a little, there we are. That means a half times something has to make 15x, so that's going to be 30x. And a half times something has to make negative 11 halves, so that's going to be negative 11. So we've managed to make that a bit more presentable. Now, if you look back at the original question, it was stated using a root format rather than a program format. So it would be a good idea to put it back into that arrangement. Here we have a numerator and a denominator. This negative power tells us that we're looking at a reciprocal. And this is technically over 1. This 30x minus 11 is in the numerator. So what we can do is we can start writing this as a fraction. And we can put the correct things into the correct places. So half looks like that. The 5x plus 1 to the negative a half can be treated like that with a positive half. And that 30x minus 11 can sit up there, technically inside a bracket, but it's the only thing in the numerator, so I'll not bother writing the bracket. So what we have is 30x minus 11 all over 2 root 5x plus 1. There we go.